Hello everyone. So today let's solve the problem Santa Clauses and the Soccer Championship. Right. So now this was asked in the Codeforces around 389 for the division 2. Right. So it is based on the Technocup 2017 elimination round 3. Right. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So yep. Let me let's see what the question states here, right? So given a tree of n cities, so we have been given a tree of n cities and 2k special hometowns, right? Where we are given a tree of n cities and 2k special hometowns, right? So we have to pair the 2k teams into this one. We have to pair the 2k teams into k pairs, right? K pairs, and we have to choose the minimum number of m cities to the house. Minimum number of M cities to the house to house them so that each pair lives in a single city, right? Lying on the shortest path between the two hometowns, right? So what we need to do, we have to output the M, the chosen city indices, and K lines with each pair UVX. So this is the thing that we need to output. Just keep this in mind. Let me read out the question loud. Just listen to this carefully. We have been given a tree of N cities and 2K special hometowns, nothing but the teams here, right? We have to pair the 2k teams into the k pairs, right? So we have to team the 2k this one teams into the k pairs, and we have to choose the minimum number of m cities to the house to house them so that each pair lives in the single city lying on the shortest path, right? Lying on the shortest path between their two hometowns, right? So we have to output m, the chosen city indices, and k lines with each pair, right? So we can give just uvx in the format uvx we need, the output basically m followed by the k lines with a each pair uvx, these three things, right? uh this we can consider this one as teams, this one teams u and v paired and living in the city x, right? So that is what we need to do. Just give me a second. In the this one, see here we have been given question, this one, what do we call, n equals 6. This is the input output part. N we have been given 6, k we have been given 2. So these are the edges basically. These are the edges. So I can just represent in this way. 1 they have given, 1 to 2, 1 to 3 basically. Then we have 2 to 4, this one, 2 to 5, and finally 3 to 6. So these are the edges. So these are the specials. We can just call this one as specials, 2, 5, 4, 6, whatever they have given. So these are the specials basically, right? So this is the build that I have shown you, the edges that they have given, right? So this is the graph. This can be represented in this way, the edges that they have given, right? For the considering this input, right? So the output that we need to get here is this one. We have to output m, the chosen indices, and the k, right? So this one, see, 1, 2, along with this one, k lines with each pair, right? So uvx, we need to uh, display the output in this format UVX, right? So this one, see, 542 and 622. This is fine, I believe. Let me delete this one. I hope you have idea. NK, this is edges, and this one we can just call this one as specials basically, right? Just remember this. Let me delete this one, man. Now, before yeah, now we have the idea on the question and this one input output part, right? So before hopping into writing the code, let's discuss the approach and the complexities part. So let's discuss the idea first, right? Let's discuss the idea first. So let's pick one city, nothing but the we will be picking one city, right? Nothing but we can just consider this one, that one as root initially, right? So we'll be picking one city, nothing but the root, so that at least k special nodes are in its DFS, right? So that at least k special nodes are in its DFS subtree, right? Then what we will do, at least k subset, this one, what we call special nodes are in the DFS subtree, right? This is fine. Now we will collect, then we will collect special nodes in the DFS order, pair the first k with the next k and settle all the pairs at the root, right? So initially m will be equivalent to the 1, right? So that's what we'll be doing. This is the idea, right? This is a simple idea. Let me tell you again. We'll pick one city, nothing but the root, so that at least k special nodes are in the DFS subtree, right? We'll collect the special nodes in the DFS. What we will do, we will collect the special nodes in the DFS and we will pair the first k with the next k. We'll pair the first k with the next k, right? And settle all the pairs at the root, and settle all the pairs at the root. So this is the basically, this is the idea. So let's consider this one itself. What do we call first example? Let's see. They have given only one example for this particular question, right? Let's consider the same, this one, right? So we have n equals 6, this one, k equals 2. We know this k, we have been given 2, and edges we have already considered this one, 1 2 1 3 2 4 2 5 and 3 6, and specials we can consider this one as specials, 2 5 4 6 we have. First, what we will do, let me tell you, we will be making use of the DFS mainly to solve this problem, right? So mainly we'll be making use of the DFS to solve this particular problem. What we'll do, we will run DFS from C of 0 initially, right? This is just the variable name. You can just consider anything. So we will go with C of 0 equals to 2 initially, right? So we'll perform the DFS. During the DFS, we count this one. Sub of x, right? Sub nothing but the subtree. Sub of x equals number of special cities in the subtrees, right? Number of special cities in the subtrees, right? Of basically x that we are considering. So sub of x we are considering right here, this one. So we'll run the DFS from C of 0 equals to 2, and during the DFS we count the sub of x equals number of special cities in the subtree of the x. And also what we will do, we will append the special nodes to list PS. We will append special nodes to list PS, right? So let's consider the same this thing, what we call variable names we have considered here, so that we don't get confused when we write the code, right? So I'll be explaining with some variables here, and I'll be considering some other variables in the code. That doesn't work, right? So whatever the this one variables we have considered, let's consider the same variables within the code as well. I'll note that, right? So we'll also append the special nodes to the list PS in the order we encounter them. Just keep this in mind. This is the first point basically. This is fine. Let's move on with the next point, man. Next, what we'll do, we'll set the root of the first node. We'll set the root to the first node, right? This one, as I have said, we'll consider one root and we will move towards the other, right? Others basically, we'll set the root to the first node. We'll set the root to the first node whose sub of root is greater than or equal to k. Whose sub of root is basically it is greater than or equal to k. Just remember this one, right? And here root will be equivalent to 2. Root will be equivalent to 2, right? Accordingly with this one uh, example, basically here root will be equivalent to the 2. This satisfies that basically. It covers at least k equals to 2 specials in it, except k we have been given 2. So this satisfies that this one, what do we call it, covers at least k equals to 2 specials in its subtree, right? So this is the second this one point, right? So this is simple one, right? First and second one are simple. We are clear with this. Now what we will do, we will once PS contains all the 2k special nodes, right? Once PS we have already appended PS here. Once PS contains all the 2k special nodes, right? Special nodes, I'll just write here SN. Once PS contains all the 2k special nodes in the DFS order, what we will do, we will pair PS of 0, PS of k, and PS of 1 with PS of k plus 1. Each pair settles at the root, right? So this will be the basically answer, right? So PS, once PS contains all the 2k special nodes, we will be going with, we will pair basically PS of 0 with PS of k, PS of 1 with this one, PS of 0 we are pairing with PS of k, PS of 1 with PS of k plus 1, next element, right? So PS of k plus 1, right? So each pair settles at the basically root. Each pair special this one settles at the root. So in the sample, whatever the question this one input that we have considered, so we can go with the output this one. What do we call? So this is nothing but the m. So this is nothing but the k. Sorry, this is nothing but the root, right? So we have to display the root. So this is m. This is the root, and pairs we have got here as, so this is nothing but the pairs that they have asked in the question criteria, right? So these are the pairs 5 4 2 UVX and this one also, this one as well. This is also one of the pairs, two pairs we have, right? 542 and 622, right? So here, each printed pairing is a valid pairing, right? So whatever pairing 542 and 622, it is a valid pairing that respects the leaving city lies on the path between hometowns, right? Condition becomes 2, right? Lies on every chosen pair's path. So whatever we got. So this is the approach that we will be going, right? The output that we got matches the output that they have shown within the this one, example 1, right? Within the question. So now, as we have completely, mean, I mean, as we have this one, as we have completely familiar, or as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part one. So what will be the time complexity here? Just give me a second here. The time complexity would lead to big of n. So why it is big of n here? Because we will be going with a one DFS across the tree, plus we'll be going with a linear input processing, right? So obviously overall time complexity would lead to big of n. So what will be the space complexity here? The space complexity would lead to big of n as well, because we'll be making use of the adjacency lists array, arrays f sub as I've considered, and the list ps as well, right? F sub and list ps that uses linear space. So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So we'll be making use of this one, fast input output and different utilities, right? So let me import here input output package, as well as let me import util package as well. This is fine. So the next step would be, let's go with a main class. So I'll just go with your public class main, right? So within the, you can just give any class name. I'll just give main as usual, right? So we'll be going with a main. Give the class name that's relevant to the problem basically, right? So first thing here would be, let's initialize certain things. Let's go with the adjacency list for the tree. So this is one index, just remember this one, right? So I'll just go with static here, list again. So this one will be list integer. Yeah, let me make this one capital I. This is fine. I'll just opt the variable name g. Also, let's initialize f and sub as well, which are of the type integers, right? So sub is nothing but the number of special nodes in the subtree of x. We have considered this one within the, we have discussed this one within the approach, right? So this way now, f of x is nothing but it's initially 1 if x is one of the 2k special hometowns. Else f of x will be 0. Just remember this, right? So now we have to initialize ps as well. Ps because it will store the special nodes in the order they are first encountered in the DFS. We have discussed this one in the approach, right? So I'll go with static here, list of integer. Let me go with a ps, right? So this is fine. Finally, let's go with the root that will hold the chosen city where we settle, right? So I'll just go with static here, and root equals 0 comma k. This is fine. Yep. Now let's do one thing. Let's go with the DFS to compute the sub and to collect the special nodes on the DS, right? So I'll just go with the static here, void DFS. So let me go with x as well as p, right? So this is fine, man. Initially, sub of x equals f of x. This is fine. Yep. We will record the special node in the order that is found. So I'll just go with if f of x equals 1, then ps is the variable name that we consider, right? Ps dot add of x. This is fine. Now we have just recorded the special node in the order that is found. I'm speaking about the if condition. This one, line number 12 I'm speaking of, right? Now let's move on with the next step. So let's iterate the neighbors of x now. Let's move on with the iteration. So this one will be int w of c dot get here. So this one of x. This is fine. So within the for loop, let's do one thing. Let's skip the parent to avoid going back, as well as let's recurse into the child and accumulate the special counts from the children. Right. So these three things. Let's do this one quickly. So let me go with continue. So let's recurse into the child. So this one we have considered W as well as X we have to consider, right? We have considered W. Yep. This is fine, man. Next, we have to accumulate the special count from the children. Now this will be sub of X equals sub of X plus sub of W, right? So this is fine, man. Now let me come out of this one entirely. So if the subtree of X has at least K specials and the root not set yet, then let's set the root equals X. So this one will be if sub of X, this one, if it is greater than or equal to K and root equals 0, then let me assign root equals X, right? So this is fine. Let me come out of this one entirely. Now let's go with the main. So this one will be, let's consider throws, what do we call? I'll just give here input output exception or else we'll get the error man, right? So this is fine, I believe. Now within the main method, let's go with the first input and the output setup buffer reader and the print writer, right? So buffer reader here equals buffer reader. Let me make use of the input stream reader system dot n. Also, let's go with the print writer for the output. Print writer. The new print writer. This one will be buffered writer output stream writer of system dot out. Basically, this is fine. Yeah. After doing this, let's consider this one string tokenizer as well. So we have to read the first line n and k, right? So let's make use of the string tokenizer here. Yep, string tokenizer. This is fine. New string tokenizer buffered reader dot read line. So this is fine, man. Yep. Now let's do one thing. Let's go with the number of nodes as well as the number of pairs, right? So that's what they have given in the first line. So this one, both are of the type integer. Integer dot, we have to parse n and k in simple terms. Percent string tokenizer dot, let's make use of the next token here. This is fine. Let me copy the same thing and just change the variable name here. Instead of n, let me go with k. This is fine. Yep. Yeah. So k we have already considered, I think, man. Yeah. So I don't have to mention int here. So I believe I don't have to mention int here. So this is fine. Yeah. Next, what shall we do here? Let's initialize the adjacency list. Nothing but which is of the size n plus one for the one based indexing. The same thing we discussed within the approach as well, right? Equals new. So this one will be array list of, as I've said, size n plus one. This is fine. Let's move on with the for loop. So this one will be for int I equals 0, I less than or equal to n, I plus plus. So this one will be g dot add new array list. This is also fine. Next, let's do one thing. Let me assign f equals new int of n plus 1. Right? So we are just marking the special cities here, man. After marking the special cities, let's go with a subtree that counts initialization. So this one will be sub equals new int of n plus 1. Also, let's go with the list to collect the special nodes in the DFS order. So I'll just go with PS equals new array list. Somewhere I have given array list wrong as well. Just give me a second here. Let me correct here as well. Did I use array list anywhere? No, here as well, right? This is fine. Yep. New array list. So let me complete the syntax. This is fine. We are done with the initialization part. Now let's read n minus 1 edges and build the undirected graph. We are going with we are building the undirected graph, right? Let's read n minus 1 edges first, all the edges, and build the undirected graph. So I'll just go with for loop here. This one will be int I equals 0, I less than n minus 1. So within the for loop, what shall I do? Let me create the instance of string tokenizer here. String tokenizer next token. This is fine. Yep. We have to read A and B here. A, let me copy the same thing. Yep. Also, let me go with int B equals the same thing. Now, we have to add the edge undirected graph, right? So we are reading n minus 1 edges and building the undirected graph. So we have to add the edge from A to B as well as from B to A. So again, so we'll go with the get operation, right? So get of A and we have to add B. So I'll just go with a B, add of B. The same thing. Let me type this one, man. G dot get again B, add of A. This is fine. Now let me come out of this one entirely. Now we are left with certain steps only, right? So now we have to read the 2k special hometowns. So I'll just consider the variable c and let me assign this one to the new int of size 2 into k. This is fine. String tokenizer equals new string tokenizer of buffered reader dot read line. So I'll just go with a buffered reader dot read line. Simple. Let's go with a for loop here for I equals 0, I less than size 2 into k we have considered, right? So this one has to be 2 into k itself. This is correct. Let me yeah, increment the I. So this one will be c of I equals integer dot parcent. So this is fine of string tokenizer dot next token. String tokenizer dot next token. So this is fine. Finally, we have to mark the city C of I as special. That's what we need to do. So this one has to be within the F, right? So F of C of I, this one, let's mark this one as special, nothing but let's assign this one to the 1, right? So we have discussed this one. Else we have to go with the 0, right? If it is special, then we have to assign that one to the 1. We know this one, right? This is simple. Now we have already written the DFS helper method here. This one, let's make use of the DFS or let's perform the DFS over here. So we will be running the DFS from the first special city C of 0, right? It will visit the whole tree basically when we run the DFS, right? We'll be running the DFS from the first special city. So why am I pronouncing PT? Right. So this is fine. We'll be running the DFS from the first special city C of 0. It will visit the whole tree. Just remember this one. DFS of we are running this one from the first special city, right? C of 0 with a 1. Else minus 1, right? We have to go with. This is fine. Yep. Now, let's output the minimal number of the cities, nothing but m equals 1. We settle in single root city, man. Let me go with out dot println here. Let me pass 1. Finally, let's print the chosen root city where all the pairs will be settled. So this one will be out dot println of let me pass the root here, right? Now let's do one thing. Let's pair the first k collected specials with the next k collected specials. Let's move on with the iteration in simple terms actually. And I equals 0, I less than k, I plus plus. So within the for loop, let's print the hometown 1, hometown 2, and the settling city, right? So that's what they have asked in the question as well. So let me go with out dot println here. So I'll just go with ps dot, let's make use of the get operation, get of I. This is fine. Also, we have to go with the hometown 1, hometown 2, as well as the root. Hometown 1, I. Hometown 2 will be going with a k plus I. And this one, settling city, is nothing but the root, right? So this one, we have to leave the space as well. Let me leave the space here. UVX, right? I'll just go with ps dot get of k plus I. This is also fine. We need one more space here. Along with that, let's append the root as well. Let me pass root here. This is fine, man. Finally, we are done with the code. We have to flush the output to ensure it the output appears, right? So I'll just go with out dot flush here. This is fine. So we are done with the code, man. This is it for the code. So let's do one thing. Before checking the code with the different input outputs, let me copy paste the inputs before this one, checking the code with the different inputs or the examples. Let me copy paste the signature starter template. Just give me a second here. So I'll paste this one over here, man. Right? Yep. I'll just come here. Let me copy this one. The output that I need to get here is 12542 Right? So this is fine. Semicolon expected. I have given colon. Line number 26. Let me change this one, man. Yep. I run this one now. We have, oh, we have 7 errors. Okay. Static void, I have to leave the space here, line number 28. Let me run this one again. So many errors are gone, 2 errors are gone. This one, I has to be capital, line number 25. This is fine, integer. Now we are left with 4 errors. G equals array, I have misspelled the array list here, line number 48. This one, let me give R here, and this one again. Yep, we are left with 3 errors. Again, array list spelling, 49 and 53. 49, yep, 53, yep. Let me run this one. 2 errors has to be gone. Yeah, we are left with 1 error. What is the error here? Error cannot find the symbol next token. String tokenizer, we are making use of. We are next token, it's fine, right? Line number 56. So this one, what we are doing here, for loop, 1 second. So this one, we are just creating the instance of it, right? So why I have given here string tokenizer. We're just, yeah. No suitable constructor found for the string tokenizer. 1 second. One second, man. Oh yeah, we have to go with a buffered radar dot readline. We are making use of the buffered radar, right? Did I go with the string token dot next token? Yeah, that was wrong actually. Sorry. Yeah, now we are getting the output 12242 as well as the 652, right? This is also correct actually. We can have the multiple outputs. All we need to print, they have strictly given here, right? So if there are several possible answers, print any of them, right? So we can just print any of them. So this is one of the valid outputs as well. So we'll just be going with the code. So I thought this will not work once I implemented this one in the form of code actually. So this worked. When this worked and you know the approach, you won't be touching the code further, right? So let me copy this one entirely. Yep, let me paste it over here. This one, it's 752, right? So let me give here 752. Along with that, let me paste the question. right? Yeah. Now let me hit the submit button. I hope this works for all the test cases. Let's see. Running on test one. Let's wait for some time. How many test cases are there? Yeah, you can clearly see here the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases, right? So we have made use of the simple DFS to solve this particular problem. And this was simple basically, right? So yeah, this is simple. It's rated 2300. It's kind of medium difficult question, man. Yep. Right. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.